All right, now we're on to the last page, the back of notes 2.2, the fourth page there, the very back. And we're talking about this right here. Since 2 points determine a line, one way to graph a linear function is to find the points at which the graph intersects each axis and connect them with a line. The y-coordinate of the point at which a graph crosses the y-axis is called the y-intercept. Likewise, the x-coordinate of the point at which it crosses the x-axis is called the x-intercept. So let's take those and let's highlight those to make sure you got it. So we're talking about the y-coordinate where it crosses the y-axis is called the y-intercept. That makes sense. And then the x-coordinate of the point that crosses the x-axis is called the x-intercept. You look at the example that's down below here, you can see the y-intercept, or the y-intercept is where it crosses the y-axis. The y-axis is here. Oops, got my wrong color. Let me just make my pen black here. So the y-axis is here, if I could draw it straight, and the y-intercept is right there. Okay? And then the x-intercept crosses through the x-axis, which of course the x-axis is here. So the x-intercept, which we made green, is going to be this point here. Notice the ordered pair. In the x-intercept, the y is a 0. In the y-intercept, the x is a 0. Makes sense. If x is a 0, you have a y-coordinate. And for the x-intercept, when the y is 0, you have your x-coordinate or x-intercept. And the bottom line is, if you're going to use the intercepts to graph, as it says right here in example 4, find the x-intercept, find the y-intercept, and then graph this equation. So all you got to do is do the x-intercept. That's when y is 0. So where y is, you put in a 0. You solve the equation, and you end up with x equals -4. So -4, is your x-intercept. And then for the y-intercept, that's when x equals 0. So the x gets taken out, you replace it with a 0, and then you solve the equation, and you get y equals 8/3, which then would be your y-intercept. So 0 is the x, 8/3 is the y. So using the intercepts helps you graph a straight line real easily because you only need 2 points to graph a line. All right, so let's take a look at this guided practice number 4, where it says, find the x and y intercept of the graph 2x plus 5y minus 10 equals 0. I am going to use a t-chart, and I'm going to put my x here and my y here. So if I want to find the y-intercept, the y-intercept is when, remember we talked about this, so y-intercept is when the x is 0. Y-intercept, x is 0, okay? So keep that in mind. So I'm going to scroll, y-intercept, the x is 0. So I'm going to put a 0 in where the x is. That's the input. So if I put in a 0 for the x, 2 times 0 is 0, plus 5y minus 10 equals 0. I'm going to add 10 on both sides. These cancel out. 5y plus 0 is 5y. 0 plus 10 is 10. Divide by 5 on both sides. And my output is 2. So 0, 2. Now to do my y-intercept, my y-intercept, okay, I'm sorry, that is the y-intercept, sorry. I gotta say, to do the x-intercept, I need the y to be a 0. So I put in a 0 for the y. So let me go down below here. So I still have 2x. 5 times 0 is 0. So I can just eliminate that. Minus 10 equals 0. Add 10 to both sides. So I get 2x equals, oops, that's a 0 there. 0 plus 10 is 10. Divide by 2, x equals 5. So when you keep a t-chart, you have these inputs and outputs, which are really ordered pairs. So this is really 0, 2. And this one here is really 5, 0. Then to graph it, let me use red for my y and my x axes. And I'm going to graph 0, 2. X is 0, y is 2. That's my y-intercept. That's what I had right here, my y-intercept. And my x-intercept is 5, 0. That would be over here somewhere. And then you would you get a straight edge, and you make sure, maybe a ruler or something, you just make sure it's straight through there, and that's your line. There's your y-intercept, here's your x-intercept. Okay, the last thing I want to talk about is something that's found in the study tip section right here, which is on the left-hand side. And this is all in your textbook. All this is in your textbook. It's great, man. This is lesson, 2.2. It says a vertical and horizontal lines. Let's see, study tip. Talking about vertical and horizontal lines. When C represents a constant, like 4, 1/4, 3 1/3, -8, you can write an equation in this form, x equals c, and it represents a vertical line with only an x-intercept. When you write y equals c, you end up with a horizontal line with a y-intercept. A horizontal line just has a y-intercept. So the vertical line has an x-intercept. So let me explain that to you using this blank page I have right here. What we're trying to say here, what that is saying is, let me write an equation, x equals 3. That is a linear equation. You might say there's no y's. Remember, ax plus by equals 0. Ax, the a is a 1. You can have 1. By, there is no y. Remember, the b can be a 0, so it eliminates that term. Then you have an integer on the other side, like the 3 here. Now, what does this look like if you made a t-chart? Inputs and outputs. Well, x is 3. If x is 3, y could be anything. If x is 3, you get a -1. If x is 3, you can have a 0. If x is 3, you can have a 10. If x is 3, you can have a -10. Now, when you go to graph that, let me use red for my x-axis and my y-axis. Graph 3, 1. If x is 3, y is 1, it's right there. 3, -1. There's 3, -1 is right there. 3, 0 would be the x-intercept. And this is special. That's your x-intercept right there. And then you have 3, 10. 3, 10 would be up here somewhere. 3, -10 would be down here somewhere. And if you connected all those points, you have a vertical line. And you know, and I know it. Is this relationship a functional relationship? The answer is no, because one input gives many outputs. But this is what the equation would look like. It's linear, but it's not a function. Okay? Now let's look at the other thing. Let's look at the other idea. The equation y equals 3. That's also a linear equation. It fits the ax plus by equals c form. But the a is the 0 this time. Okay, the AX, the A times X would be 0. There's no X term. And what does that look like in a T-chart? That means it doesn't matter what the input is, the Y is 3. So if X is 1, Y equals 3. If X is 4, Y equals 3. If X is 0, Y equals 3. If X is negative 10, you guessed it, Y is 3. So if you go to graph this on a coordinate plane, X-axis, Y-axis, and you graph 1, 3. X is 1, Y is 3. 3 is, let's say, right there. There's 1, 3. Oh, no, it's not. It's over here. Let me erase that. I just did negative 1. That probably doesn't matter anyways, because, so 4, 3 would be here. 0, 3 is right on the Y-axis. So that's actually your Y-intercept. Because the X is 0, Y is 3. It's right there. Then negative 10, 3 is way down here. So negative 1, 3 would also work. And if you connect those, you have a straight line that's horizontal. So a horizontal line can look like this. Y equals 3. Y equals 5 would be up here. Here's Y equals 5. Y equals negative 10 would be down here. They're all horizontal lines. But then you have X equals 3. What if you had X equals 5? That would be out here. What if you had X equals negative 1? That would be a vertical line over here. So just be aware, those are also equations where the X is always 3. Or in this case, on the right side, Y equals 3 is a straight line where the Y is always 3. So take a look at the T charts. Hopefully that helps you understand horizontal lines and vertical lines.